Welcome back. We're going to talk about rational functions and their graphs. This is video number 2 where we talk about horizontal asymptotes. So here we go. All right, so now last time we talked about vertical asymptotes. Remember, an asymptote is an imaginary or an invisible boundary line. Okay, and so rational functions have vertical ones. They might have horizontal ones. They might have slanted ones, but they're all invisible lines that are boundaries for our graph. Okay, and so vertical ones are in the previous video, so go watch it if you don't know. Now we're going to move into horizontal asymptotes. Now these are the rules. All your rules are printed out and given to you, so make sure that you print them out and have them in front of you so that you have all of them. I'm going by them step by step. So here's the second one, the horizontal asymptotes. What we do here is we compare the degree of the numerator, which we call n, to the degree of the denominator. Now remember, the numerator and the denominator are polynomials, and you should know how to do the degree of a polynomial because we just finished doing polynomials. Okay, now the ones that I give you are pretty small degree polynomials, but you should still be able to determine the degree. Okay, so when we compare the degrees, and we have to figure out if it's big on top, big on bottom, or the same. So in the first one it says if n is less than d. So that means the denominator is bigger. All right, so this one's big on bottom. So when it's big on bottom, then the y equal 0 is the asymptote. Now this is actually the x-axis, which means that the x-axis acts as a boundary line. Okay, and so, but again, the x-axis is a horizontal. So y equals 0 when the degree on the bottom is bigger. All right. Now, the second one says if they're the same. If the degrees are the same, then we have to go look at the coefficients. Remember, the a number is the first number in our polynomial. We're used to that. A is that first number in our polynomial. And so the a of the numerator over the a of the denominator ends up being our horizontal line. And so we create a little fraction out of what that is. All right, so then the third case is when the numerator is bigger. This one's big on top. Now, when it's big on top, there is no horizontal asymptote, none at all, none at all. But you might have an oblique one, which we'll talk about the oblique one next after we finish this one. But we might have an oblique one. Okay, just depends. We'll look at that in just a second. So let's look at these 4 examples I have real quick. There is no math required here. Now, the help features on your homework might have you do some fancy math, and I'm telling you not to do it. I'm telling you and warning you ahead of time that this is the easy way. Don't use the help features on everything because they might take you down a path that you're like, I have no idea what they're talking about. This is much easier. Follow the rules. Okay, so first example. All right, we need to know the degree of the numerator and the degree of the denominator. Now, this is a really small polynomial. The numerator has a degree of 1. This is degree 1. And the denominator has a degree 2. So this one is big on bottom. The denominator is bigger. So our horizontal asymptote is the line y equals 0. That's the horizontal asymptote. Now please, when you are typing these in, if it says type an equation, you type in the y and the equals and the 0. Okay, because it says type an equation. So read your homework carefully. If you remember equations of lines, and let's just really hash that out real quick. Remember equations of lines? We did equations of lines a long time ago. We had vertical lines where x equal a number. Horizontal lines were y equal a number, and slanted lines was y equals mx plus b. You're like, oh, I remember that one. I don't remember the other two. Well, they were all three there. You know the slanted ones are y equals mx plus b. Well, the vertical ones are x equal a number, and the horizontal ones are y equal a number. And so these are horizontal. So if it says type an equation, you've got to type in the y equals. Okay, keep going. All right, so the next one. This one has degree 1. This one has degree 1. Ooh, that one tricked you, didn't it? It wasn't the lead. You have to look for it. Sometimes when they're not written in order, it makes it complicated. So since they're the same, we have to use the actual numbers. So the numbers are 3 over 4. And again, you type in the equation. All right. The third one. This one's a third degree. This one's big on top. So no horizontal asymptote. None. No horizontal asymptote. It does not have one. Now it might have a slant. It might have a slant. We'll go there in just a minute. Might have a slant. Okay, and then the last one, again, we've got 2 on top, power of 1, no horizontal asymptote. Okay, so now what makes this hard is that people think that there's some crazy math going on, and literally you just looking at the rules and looking at the problem. And so your studying for pre-cal has to be different because there's no math to be done. It's rules. You look at the problem that you're given and the exponents, the format, or whatever, and you compare it to your rules and you make decisions. And you say, yes, there's this, or no, there's that. So it's different. Okay, that's horizontal asymptotes. Okay, let's move on into the oblique ones. Okay, so now the oblique ones, also known as the slanted ones. If the degree of the numerator is exactly 1 greater than the denominator, then you have an oblique. Okay, so now let's look. We had 2 examples before. I'm just going to pull up one of them. Or I'm going to come up with, actually get you a different one. Okay. So this one says f of x is equal to x squared over x plus 7. All right. So now we look at it and we see that the degree of the numerator is 2 and the degree of the denominator is 1. It's just 1 more. So this is the case for an oblique. Okay, it's big on top by 1. Big on top by 1 degree. Exactly. Okay, so now how do we find it? It says you have to divide. And it says use long or, if applicable, synthetic division. So we're going to use synthetic division here. All right, and so we have x to the second, which is 1. And then a 0x, and then a 0. Ooh, I forgot about all those zeros. Let's look at them. Remember, it's x to the second plus 0x plus 0. All right, and then what do we divide by when we do synthetic? Remember, we have that sign change. We're going to divide by the -7. So we're going to use synthetic division to divide. Okay, so here we go. So -7 times 1 is -7. 0 plus -7 is -7. -7 times -7 is 49, and 0 plus 49 is 49. Okay, so now if you remember, this guy right here is our remainder. We don't need him. We Also remember that when we started out with an x squared, we do a division, we have a plain x. And so our asymptote is y equals 1x minus 7. Remember, that's in the format of a slanted line. mx plus b, 1x minus 7. And so this is my oblique asymptote for this particular problem. And remember, it says type in the equation. It's going to tell you to type in the equation, so you have to do the y equals. Type in the whole equation, or else it's going to mark it wrong. All right, let's look at another example. Oops. Don't know. There we go. Okay, so this one says f of x equals 4x squared minus x over x minus 2. Okay, all right, so now we see very clearly that we do have an oblique. Okay, we do have an oblique. That we have a second degree over a first degree. Right, and so we're going to do synthetic division to divide. And so that would be 4, a negative 1, and then a 0. And we're going to use 2 to divide with. So I'm going to bring down my 4. And then 2 times 4 is 8. Negative 1 plus 8 is 7. 2 times 7 is 14. 14. That's the remainder. I don't need it. Remember, this is going to be an x. So my answer is y equals 4x plus 7. And again, that's in the form y equals mx plus b. And that is the equation. Now, be careful. Some of the problems already have the y equals typed in. This one's already typed in, so be careful that you don't double type it because it will mark it wrong. Okay? All right. So, one more problem real quick. This one says, find all the asymptotes. It says find the vertical, the horizontal, or obliques. Now, here's the deal. Remember, you're not going to have both horizontal and obliques. All right? So here's the first question. It says x squared minus 6 is your numerator, and x plus 4 is your denominator. Okay, so to find the verticals, set the denominator equal to 0 and solve. So x plus 4 equals 0. X equal negative 4 is my vertical asymptote. Horizontal. Compare the degrees. It's big on top. No horizontal asymptote. None. Okay. All right. Might have a slant. So now we're going to question our slant. So our oblique, that's what the other word for slant is. Okay. So big on top by 1. 1 degree bigger? Yes. 1 to be exactly 1 degree bigger. So we're going to use synthetic division. 1, 0, negative 6. And we'll divide by negative 4. I don't need my remainder, so it's going to be y equals 1x minus 4. That is my oblique or my slanted asymptote. All right, there you go. All three. The vertical was x equal -4. There was no horizontal, and the slant is y equals x minus 4. All right, it's just math, y'all. Keep plunging along. You can do it.